All right, so one common practice in the chemistry lab is to make dilutions of concentrated solutions using volumetric glassware. For example, this is a picture of a volumetric flask. And volumetric flasks come in all different sizes, but they are calibrated for exact volumes. And this little line here corresponds to the exact volume that the flask is designed to measure. In this case, it says 10 milliliters. So this would be your measuring line. So using glassware like this, you can make dilutions of concentrated stock solutions. So often a lab will stock very concentrated solutions, for example, lots of concentrated acids, but you never use those solutions at full concentration. You have to dilute them to make concentrations that you can use in chemical reactions and such. So we need to know how to manipulate molar concentrations through stoichiometric calculations to figure out how to make these kinds of dilutions. For example, how do you prepare 250 milliliters of 1 molar HCl from 12 molar HCl? So this is an example of a situation where we have a concentrated stock solution. Okay, 12 molar HCl is extremely concentrated. And we have to dilute this super concentrated 12 molar solution to a much lower concentration, 1 molar. So it's going to be, a dilution. We want to make it 12 times less concentrated. So we can approach this the same way we've been using the unit factor method. We have 250 milliliters of 1 molar solution. So I'm turning that of into a multiplication sign. Molar, of course, stands for mole per liter. So that big M can also be expressed as moles per liter. And this is going to be how much of the solution I how many, this is going to give me how many moles of HCl I have in the desired solution. I have to convert the unit. Okay, I have to convert milliliters to liters here to make the volume units match so that I can cancel out the milliliters and cancel out the liters. And this will tell me how many moles I want in that dilute solution. So I want 0.25 moles of HCl in my solution. So I need to figure out how much of the stock solution is going to give me 0.25 moles of HCl. And I can do that by basically taking that number of moles and dividing it by the concentration of the stock solution. Or another way of saying that is I want to get 0.25 moles of HCl from this 12 molar stock solution, okay? So that 12 molar stock solution, I can take the reciprocal of it, and that will enable me to cancel out the moles of HCl so I can figure out the volume of the stock solution that I need, 0.021 liters. I can convert that to milliliters if you want, 21 milliliters. So we're not done because the question asks, how do you prepare this dilute solution? What I've done so far is I've figured out how much of this is the volume of the stock solution that you need. But you need to really think about this problem and what it's asking. We want to make 250 milliliters of a more dilute solution. So what we need to do is take those 21 milliliters of the 12 molar HCl, and I want to dilute it to 250 milliliters. So what you would do is you would pipette this 21 milliliters of 12 molar HCl into a 250 milliliter volumetric flask, And then you would add water up to the line. So you would dilute it to 250 milliliters with water. So really what you're doing, in practice, you don't need to actually figure this out because you're using a volumetric flask, but you're adding 250 minus 21. So what does that come out to be? Uh, 229 milliliters of water must be added. Okay, so that's the subtext here. You, in practice, would take the 21 milliliters of the concentrated solution, put it in a 250 milliliter volumetric flask, and then add enough water to get up to the line. So we just thought hard about how to do that problem. But another way to think about dilution problems is to use the master equation M1V1 equals M2V2. Using this equation, on one side you have the molarity and the volume of one of the solutions. I'll just call it solution 1. And on the other side, you have the molarity and the volume of solution 2. It doesn't matter which is which as long as you stay consistent, of solution number 2. So I could have used M1V1 equals M2V2 to solve the problem that we just did. In this formulation, M1 would be, let's just say it's 12 molar. V1 is what I'm trying to find out. I'll call it X, or too many variables. I'm just going to give it a question mark. M2 is the volume, I'll just say it's of the dilute solution, and I had 250 milliliters of it. So if I plug those numbers into this equation, M1V1 equals M2V2, and then I solve for V2, okay, let me do that up here. No, I'm solving for V1 rather. V1 is going to be equal to M2V2 over M1. That's going to be equal to 1 molar times 250 milliliters. I can leave it in 250 milliliters just knowing that my volume is going to be, actually, you know what? I don't want you to do that yet because I don't want anybody to get confused. Just convert it to liters. Make sure it's liters just so that you're consistent at the beginning before you get used to doing this. And then you're going to divide it by 12 molar. And that will give you the same number of 0.021 liters. Okay. So that would be the 21 milliliters that we figured out earlier for the amount of stock solution. So you could use either thinking about the stoichiometry, or you could use the M1V1 equals M2V2 equation to do these dilution problems. Let's do another problem quickly. The saline solution used in hospitals for IV infusion is just a 0.155 molar solution of sodium chloride. It is made from a concentrated stock solution of sodium chloride by diluting 5.28 liters of that stock with water to make 60 liters of the 0.155 molar NaCl solution. So, using this information, can you calculate the concentration of sodium chloride in the stock solution? So let's try to do this problem using M1V1 equals M2V2, our master equation. M1V1 equals M2V2. I'm going to assign, just arbitrarily, I'm going to say this is the stock solution. And that means that the M2 is going to be the molarity of the saline solution, the less concentrated solution. So 0.155 molar. And I know that I have 60 liters of that. The other thing that I know is that I have 5.28 liters of the stock solution. So what I'm trying to find out here is M1. And rearranging the equation, M1 is equal to M2V2 over V1. So that's going to be 0.155 molar times 60 liters over 5.28 liters. And that is going to give me the molarity of the stock solution as 1.76 molar NaCl. So that would be the concentration of the sodium chloride solution that is used as the stock solution to make the saline solution that is used in hospitals for IVs.